I want to write down a chain rule for paths. So I want to imagine that I have a function on three variables, w equals f of x, y, z. And this parametric function here, this vector valued function, r of t equals x of ti plus y of tj plus z of tk, is a smooth curve in the domain of that path. We can substitute x for x, y for y, z for z, and then evaluate that function along the points in that path. One way to write that down would be to simply say f of r of t, telling me that I take all of the points from that and I'm plugging them into my function to see what happens. I can write a chain rule for this situation. I have one lone independent variable, an x, a y, and a z. I put all those in to get an f. And I should label these with partial derivatives and these with derivatives with respect to t. I'll let you fill in the details there because we've written down a bunch of chain rules together. But what we get is that dw, or I want to say df dt, is the partial of f with respect to x times dx dt plus the partial of f with respect to y times dy dt, and then finally plus the partial of f with respect to z times dz dt. What I want to do now is imagine that this is a dot product, right? Because I see these products being added together, it looks like the dot product of two vectors with three components. Well, this is fx, fy, fz. That's a gradient vector. And this is dx dt, dy dt, and dz dt. So this is del f, but it's del f evaluated at points that came from r of t. Dot dr dt. I could also call that v of t, but right now I want to use the derivative notation because I want to point out that this is treating the gradient as a derivative operation. I take the gradient of f, leaving the inside alone, right, by plugging those things in, and do a dot product with the derivative of the inside. This looks just like the chain rule from Calc 1, just written in terms of a path, a vector function, a function on three variables, and then the gradient, that component-wise derivative.